Okay, so 50 degrees, we put the 30 over 60 because that's minutes. That's 50.5 because 30 over 60 would be a half. Forgot to turn the recorder on when I was blabbing away. Okay, and then we got this side is 10.4. That's I'll label it in a minute. And then they tell us this is 12.5. And they don't give us, they say use the law of sines to solve this triangle. Now, in real life, I don't know that I would use the law of sines. And the law of cosines, because if you've got an angle and two sides, and that is SAS, wouldn't it be easier to use the law of sines? The math would be easier on it. So what I would do normally, if I just had this triangle and we're asked to solve it, I wouldn't use the law of cosines, but we're practicing the law of cosines, so we're going to use it, okay? So let's do our labeling. Across from A is the side A. Across from angle B is the side B, and across from angle C is the side C. So now I've got my, what I've got is, if you look, I've got little c is 12.5, little a is 10.4, and the angle B is 50.5 degrees, which that's how we're going to want to work with it in the calculator. Okay. So if we're supposed to use the law of cosines, how do you think I'm going to pick the formula I use? How do you think that's going to work here?
We have A and C, so B squared.
So the what?
The B squared.
The B squared. And one of the reasons, too, that's one way. You've got those two sides, and then also you've got the angle B. And you know that you gotta, if you're going to have a cosine in the formula, you better make sure you have that angle that you need to take the cosine of. So the B was a giveaway that I wanted that B squared equal A squared plus C squared minus 2AC cosine B. Did I write it down right? Hopefully I did, yeah. Okay, so they want us to solve the triangle, which means they want us to find both of those angles, and so we need to find, and I'm going to write over here what we want to find just so we don't forget anything, because I tend to forget. We want to find angle A, angle C, and then side B. Now, I'm going to start finding side B, and here's just kind of an overview. I can use that formula to find that side B really quickly. And then what people usually do is they use because the law of cosines formula is so long, they usually just use it to find the first missing piece of information, and then they switch over to the law of sines to find the other stuff because it goes quicker that way, okay? So that's what I'll do here. I'll just kind of show you what most people would normally do instead of, we could beat this to death and find everything using a different formula, but, you know, part of the beauty of math is you don't have to beat it to death all the time, right? So that's what we want to kind of remember here. All right, so we're trying to find B squared first. A squared is 10.4. Then C squared is 12.5 squared minus 2 times A times C, and then we want the cosine of B, and B is 50.5 degrees. And so this is definitely something we'd want to do in our calculator. I calculate the number, I square root it, and I say, well, you know what, all the other things they gave me just to one decimal place. So if I round this to one decimal place, that 5 is going to round that 9 up to a 10. What would this number round up to? 10, which is kind of a little, I always worry a little bit when it rounds up to a whole number that people just think we were rounding the nearest whole number, but that's just the way it all rounded out, right? So we like that. It's going to be easier to work with. So B is 10. That was one of the answers I needed to find. Okay. Now, if I want to find the other two angles, I can do this with one more easy, 2 more steps. What I would do here is, if you had to find the angle, you'd have to go pick a different one of these law of cosine formulas and plug all that stuff in and solve it. It's a lot of mess, isn't it? So let's work smart. Let's do this, C or A, okay? So we know B is 10 now. We have all that other information. The law of sines, let's see, the angle that I was given here was B. So I know I need sine of B over B. And let's just find, I'll just pick A, okay? We've got A and C. It doesn't matter which one I pick. Let's say that I say the sine of A over A. I'm going to use the law of sines. Now that I've used the law of cosines to find that missing side, I can now use an easier formula and work smart. Well, B was 50.5 degrees. And now little b, the side b, was 10. So I've got now an angle, and I've got the side across from it, which is why I can use the law of sines. I don't know angle A. That's what I'm trying to find. But I do know that side A was, what, 10.4? So I can now use a much easier formula to find the second angle. Okay, so we can put this in. If you remember from back in 7th grade, you multiply the two things that are across from each other, and then, so I'm just going to do that all at once. Sine 50.5 times 10.4 is, I'm getting 8.024895667. I'm just going to keep up with as much accuracy as I can just for now. And then I multiply the other diagonal, 10 times sine A. So if I want to solve for A, I've got to first get sine A by itself. I'll divide both sides by 10. So I'm going to do that in my calculator. I'm just going to leave my long number there and say divide by 10. And now I'm getting point, and y'all tell me if you get something different, 0.024895667. And again, I normally wouldn't write this on my paper. I would just leave it in the calculator. And then if I want to find this angle, all I got to do is hit inverse sine, right? So I hit second sine, and then I can hit second and that negative key to pull up that big long value without retyping it. And I can hit enter, and what I'm getting for A, tell me, speak up if you're not getting the same thing. I'm getting about 53, let's just say 53.4 degrees, because they gave me the other angle in one decimal place. Is that what y'all got? Anybody get anything different? Okay. So I already found B. I now know that A is 53.4. Do you think I need to do the law of sines again to find angle C? I could. It's not the easiest way to do it, is it? Because if all the angles add up to 180, and I know that A is 53.4 degrees, and they already told me B was 50.5 degrees, wouldn't it be much easier just to subtract from 180 and not have to go do the silly trig formulas, right? We want to work, we want to be smart about what we do. So if we subtract all that, I'm getting it looks like C, or the remainder, which is angle C, is going to be about 76.1 degrees. And so we've solved the triangle. So if you think about it, here's what we did. We used the law of cosines to find the missing side, that last side that we didn't have. Then we took that information and we used the law of sines to get another angle. I'll just put angle like that. And then the last thing we did is to get third angle, we subtracted from 180, didn't we? Right over that. But that, that's basically what we did. So when you use the law of cosine